I don't know. I think the first half of the, oh, never mind.
Okay, yeah, that's above my
Thank
pay grade.
Thank you for the warning.
So,
Justin.
so here we are at the session 1 handout, and we're just now starting with getting our Git environment set up. Now, some of the stuff we're going to do is just going to be to look at this particular repo, but some of it, particularly the Git aliases stuff, ideally you'll be able to carry forward and just use as tools going forward. So first, just the repo specific stuff, which is this Git objects. So as I mentioned, when you pull down a repo, Git has probably packed it up into this super compressed format. So we're going to kind of uncompress it just a little bit to what it would be before you pushed it up to Git. If you're creating it from scratch, and then we're gonna make it what you would see at that point. So here we are in tags. pwd print working directory shows us where we're at, and from here we can look at .git. Now this is .git is where everything is. This is all your repo, all your history of your repo, all your branches, everything about your Git state is in .git, pretty much. So you can look at what's here, and then you can look a little further down in objects, and you should be able to see all the pieces that put your Git repo together. And I can. So let me back up a little bit and get to the state that you guys would be in. So I'm just going to blow away my tags directory with rm-rf, which is a very powerful, useful, scary command. rm-r is recursive, f is force, and then it does that with whatever you give it. So now it's gone. So I can clone it again. Pardon me while I type a little bit here. Okay, fresh repo, go in there. Okay, so now if I do the same thing that I just did, which is the ls-git objects, now I don't see anything, basically. And the reason is because it's all in this these pack files here. So, and if I put a -L on ls, you might have seen me do this once before or twice. That is long format, so that tells me more about those files or directories. So among other things, I can see the date and I can see the size. And because there's no D over here, I know this is a file, not a directory. If I go up one, just and do an ls-l, a lot of these are going to be Ds, which is telling me those are directories that I can CD into. So now if I want to go back, here's a little bash trick. If you do CD and then you give it dash, it goes to the place you were before. So you can just go back. So now I'm back in tags. And yeah, we're going to deal with this pack file now. So the way we do that is there's this little bin unpack objects.sh, which is a script that just runs a kind of a Git low-level command called unpack-objects, which you never need to know about, but it's an example of programming you can do with bash if you want. So we're just going to run it, and it is going to take those objects and put them out for us to look at. So now if we do an ls-git or .git/objects, now we see the the repo in its full glory, and we can begin to look around in it. So let's go ahead.
When you unpack, did you use -L or -1?
So when I used it, I actually just ran it like that.
Before that, up above.
Oh, up here, yes.
-L.
Yeah, I haven't used -1 yet. So I've done. Yeah, -L is what I just ran.
And how is that different from -1? Because in the instructions it says to use -1.
So yeah, -1 is just use one line. So for instance, if I do, let's go, I'll cd into git .git/objects for an example here. So, shifting to some Linux Unix stuff here for a minute. So if I just do ls, I get all these. It's arranged in all these columns. Sometimes you want to process the output in a list. So if I do -1, then it's all just a single list. And so that comes into play perhaps when you want to feed it into a for loop in bash, and you just want to process a list of things once per line. So you want to say you can do things like for I, and to digress quite a bit here, ls-1. And the backticks basically take the output of the command and use it as as part of the code. Like that. So that's the beginning of your loop, and you can echo this file, and then you can substitute it in with a $I. Okay, and then it keeps, wait until you're done with the loop, and you can say done. And then it just basically takes every file that came out of the ls-1. Now, in this particular situation, because of the way bash works, you wouldn't necessarily need the -1, but other cases you might want to, break it up into one per line. So anyway, to beat that to death, there you go. But that's how I got this, this output, instead of, like, if I had gone in without a -1, these two pack files would have shown up on the same line, kind of, next to each other like that. So anyway, that is our data, like our Git repo is now in place. Now we're going to shift a little ways over and get some commands in place in your bash profile environment that you can use going forward. So this is going to be interesting, way beyond just this repo, ideally. So let's go up a couple levels, or actually you're probably there already. Go up to the tags level. There should be a git aliases, and there's not. That is because, why is that? That's because it's in the bin directory. Okay, so cat bin/git aliases, there's an error in the documentation there, but you can do that. Can everybody do that? Does that work for everyone?
Yeah, that worked for me. Brendan put it in the chat.
Okay, awesome. Sorry about that. So,
and then that's also true of the next command. It's going to be bin/star.sh.
That is true. You're right. Yeah. So let's do that. Okay.
And now for this next one, I'm getting permission denied.
Okay. I understand why that is. And actually the bin/star will tell us. So here's some more Unix for you. We've seen that you can get the date, you can get the size. What is this? This might be like the inode or something. I forget what exactly that is. Owner of the file. This is the number of, basically a number of links that are to that file in the file system, which I won't go into right now, but this part tells you not only whether it's a directory or not, but also what the permissions are. And one of those permissions is executable permission. So all these others have executable. Notice that the X. So these are basically groups of 3, read, write, execute for each of user, group, and other. And in this case, we see that user has read, write, the group has read, and other has read, but nobody has execute permission. So let's fix that. There was a handy command called chmod, which is short for change mode, as in file mode. And we want to basically give it execute, so we can say +X, oops, +X, and then bin git aliases .sh. Now just I can just up arrow to the couple previous commands and rerun that. And now we can see that compared to before, now we have execute permission. So if that has all happened the way it should, we should be able to run it. Actually, let's look at it first. It's always good to look at your shell scripts before you run them if you're not familiar with them. So what this is going to do is put some aliases into your environment. So if right now, before you run it, you say alias a dog, you'll get nothing. Actually, I get it because I've run it already. You say alias random thing, you'll get nothing. But you can set it to something. So that's what we're doing now with this equals. Notice all these have equals. So we're basically making a whole bunch of shortcuts for Git commands that we are going to use pretty often. Like, for instance, git commit. You can type out git space commit every time, or you could just type GC. Same thing for git checkout master. I use that a lot, so I just made gcom for that. And adog is basically a way to show a graphic picture of your Git history, which I use all the time. And it's a lot easier than typing out git log -- all -- decorate -- one line -- graph. Or in, ADDog gives the date as well in a pretty format. Like, this is what all that does, is set a pretty format for your whole output with lots of colors. So with that said, let's run it. bin/git aliases. And now if we say alias space adog, ADOG, it should be set to something like that if you have experienced success. And
Yeah, I didn't get that.
what did it say for you?
Alias
You said
adog
it's
not
already.
found.
If you're able to do this, and there were no errors that came back, if you're able to run bin/git aliases.sh, should have set those aliases for you.
So we don't have to manually.
Go ahead, Christian. What do you have?
We don't have to manually create these aliases. They should be pre-made already.
Well, this script does that. So if you look at what the content of the script is, it makes those aliases. And so then when we run it by doing bin/git aliases.sh, then it executes that script, which creates those aliases. And they come into being in your environment.
Yeah, I'm still getting permission denied when I try to run the bin/git aliases.sh.
Okay, did you do the chmod space +X? Bin/.
Yeah, I tried that, but it didn't work. Try it again. I think
chmod space +X, and then if you do an ls-l of that same file, you should see X's here on the far left in your permission status. You have to have those X's there in order for that to work. Now, if that doesn't work, you can also just use bash to run it. You can just say bash space bin/git aliases.sh. And then you don't need the executable bits. You can just, then bash knows that it's supposed to run it because you've told it so. So
Yeah, I think it was it was the ch mod where I got caught up. I didn't see it in the documentation, so I did.
yes, that's my bad because I forgot to make the file executable in the first place like it should have been. So I will fix that.
So for
I
me,
did
it
that.
seems like the file is executable. I checked it, I listed it, and it looks like everything's good. But even so, when I do alias adog, I'm not. It's just saying adog not found. Alias adog not found.
I'm having the same problem.
Yeah, me too.
Okay. Have you tried a bash space bin/git aliases.sh? Just try putting a bash in front of it and running it like this with bash space. Tell me what that does.
Same thing.
Does that appear to work? Does it?
No, same issue. Exactly the same thing. Alias adog not found.
Yep, same thing for me too.
I just get a blank response. Does that mean it's working or not?
Blank response should be what you want.
I'm getting a blank response, and it's that they're not getting the aliases set, unfortunately.
So
Yeah, because then if I type alias adog, then I get nothing. I don't get a reply back there.
okay. Nothing at all. Okay, so that's interesting. What system are you running this in?
I'm running it on a Mac M1, but I'm using the ZSH shell.
CSH. Okay. Try typing it. Let's just try a test. So alias test equals. How does that work? You just do that.
Okay, I type that and then test it, and I should get it back.
So that should work for you.
Yeah, that worked.
Okay.
Yeah, worked for me too.
So when you type, when you type this, what comes back?
Just a blank response.
Yeah,
Okay.
same as what you got.
Yep.
Same.
I got the same.
Blank response, but then this doesn't work.
Correct.
Okay. Well, let's just let me take this and paste it into chat.
Same thing for me. It's all right.
Let's just yeah, let's abandon that approach and just go with this one then. So if you take that and paste that into your bash shell, what do you get?
So it came back this time. It worked. I typed in alias adog after the longer declaration, and it came back with the
Okay.
response of what that equals.
Okay.
A blank response.
I got the same thing. Jose, did you type in alias adog after it?
Type in alias adog after we pasted.
Yeah.
Correct.
Let me try that.
Yeah, this just sets it. It doesn't, you won't get any response from this, but then it should be set, and then you should be able to see what it is by just typing it without any equal sign.
Okay, I find.
That worked for me.
Okay.
First it says, like bash alias not found, and then alias adog git log all decorate online graph.
So now if you're seeing this when you type, oops, sorry. If you're seeing this when you type alias space adog, that means you should be able to just type adog itself and see something like that.
Yeah, that worked.
I didn't
Okay.
get all of that. I
Yep.
just the same thing that one line you got with the graph at the end.
So, okay, I don't know why.
Never mind, I got it. I'm sorry, I didn't see that you only typed in ADOG as itself. I put alias before it, so. never
Oh,
mind.
yeah, yeah, there's a lot going on. There's the assignment here. There's the viewing what you assigned here with alias space ADOG, and then there's actually running the thing with just typing ADOG by itself. So ADOG itself is the shortcut. You could also.
What do we do if it said permission denied?
That's an interesting one. What did you type to get that?
bin/git aliases.sh, and it says the file permission denied.
Okay, so just prefix that instead of, so put bash space and then bin/git aliases.sh. That should come back with nothing, but then you should be able to type ADOG.
You said -h.
No, it just said bash space bin/git aliases.sh. So this
Okay. Came back with nothing.
Okay. Now type alias space ADOG to see if it got set.
Not found. Bash alias ADOG, not found.
Okay, so now type cat bin space. So type cat bin/git aliases.sh. And then copy paste the top line here, right here.
Okay.
Copy, paste, enter. And then
Yep.
type alias space ADOG again.
Yep, that returned it.
Okay, so now type ADOG.
Yep,
You should
that
get-
returns that.
So we're good. Anybody not good?
Do we only have ADOG now, or did that add all the rest of the aliases?
It sounds like you may only have ADOG, but if you copy paste more of those lines, you'll get more of those aliases. So for instance, if you want git checkout, you can just copy paste the alias GCO, copy, paste, enter. And then you should be able to say GCO. Nothing will happen yet, but you'll get get that alias set.
Okay, thank you.
Yeah, same for the rest. ADOG is the one we're going to focus on because it's the longest to type if you don't have it. So as long as you've got ADOG working, we can move. So, all right. Let's see. So let's see what this shows us then. So Command K to clear the screen, ADOG. And you're probably gonna get this basically puts this thing into a pager mode. So if you hit space, you're gonna, or actually let's say down arrow, when you're in this mode, you can move down, and up arrow can move up, page down can move down. Actually, no, that doesn't work for me. So down arrow, you can also say F and B, forward and back. That moves a page at a time. So now I'm all the way up at the top of it. Now, none of this looks familiar, and I'll tell you why in a minute. The place we're looking for, you can use space to go down as well for a page at a time. So hit space a couple times, and you should get kind of down in this area where we start seeing, origin/this, origin/that. We start seeing head master. This is where we want to be. Is we want to see this part right here. Down arrow a little bit. And this is actually why we want to be there, is because this is where our repo is pointing right now. And I know that because I see this head representation here. And I see head pointing to master. So that means we're on the master branch in our repo right now. And I also see well, let's stop there right now. So here we are. So we've already explored the code. Let's explore the Git database at this point. So what does it mean to be at head and have head pointing to master? You know, so to get out, you can hit Q for quit, and you should get back on your command line. That gets you out of your kind of view mode of your Git history. So we're next here. So we've got just a few minutes. I want to cover, I guess, the data model of Git in this few minutes. So the way we'll do that is to pick a file and then look at it in the Git repo itself. So for instance, app.py, we're familiar with that, right? You look at that. That has familiar content that we've seen before. But how does app.py live in the Git repo? Right? How does Git represent that file? How was Git able to get that file out of github.com, out of that .git directory, and then constitute it into our workspace so that we could, you know, fire up the web app with it? That's what we hope to get to here. So to do that, let's look at that specific file. But to do that, we're going to have to figure out like how we're going to get from our current state down to that file. And kind of the essence of our current state is head. You saw that in the history. So I'm going to type this command here, rev parse, git rev parse, git space rev parse head. And it's a little scary, but it's not. So what is this thing here? Anybody have any guesses? Put themselves out there.
It's a hash.
It's a hash. What does that mean? What is a hash?
A hash is kind of like fingerprinting a file. So when you hash it the first time, you get this. If you hash it again, you always get the same thing if the file has not changed.
Exactly right. Yes, it's a signature. It's a fingerprint. It defines what the content of the file is. So next question then would be what file is that defining the content of?
No idea.
That's where we're going. So we can use some things to look at it. I'll go ahead and tell you this file that's being fingerprinted here is actually it's one of the three kinds of objects that Git uses. It's a commit, and we can use another sort of low-level command that you'd never use in real life to look at it. So we can take this, copy paste, and actually look at that file, like the actual content of the file. And that's why they call it gitcat file. And then -p is for print. And a nice thing is you don't have to actually use this whole long scary thing. You can just use like just enough characters so that Git knows what you're talking about, which the first 7 or even sometimes even the first 4 is enough to know what you're talking about. So I could say git cat dash file space -p and just take 778D, and that's enough for Git to say, oh, okay, I know which one you mean. So what this is actually it's a commit. It's one of those 3 types of objects, and commit is a file, and Git took the content of that and turned the contents of this into this reference. It's kind of it's basically an address of that file. And we can actually see that. Actually, let's stop there. Let's see what we've got here. So we've got a commit. A commit has these attributes to it. It's got a tree, it's got a parent, which is the previous commit. It's got who checked it in, who committed it. Actually, who authored it. Author and commit are the same thing, or they're different concepts in Git. So it distinguishes between those. And then finally, the last part is, you may not be obvious, but that's the comment for that commit. So if we were to look back at our ADOG, this would be the comment that shows up in our ADOG line for where head is pointing to. So that's type 1 is a commit SHA, and SHA is just another name for a secure hash algorithm. It's a type of hashing, and so when you see people talking about SHAs in Git, that's what they're talking about. Is just it's the hashing algorithm used to generate this hash. So, okay, a tree that looks like a hash as well. So let's see what that might look like with gitcat file again. And we'll just take the first few characters, 81A7E. How about that? 81A7E. Okay, so that's another type. That is the tree type of Git SHA. So we got the commit. Now we got the tree, and we see the tree containing some things that look kind of like files and directories, right? We now we're starting to recognize there's @py. There's a bin. That's probably a directory if we do an ls. And in fact, everything that we see here corresponds to a file or directory that has actually been pulled out into our workspace. So notice also that the things that are directories correspond to trees as their types here. Config is a directory, so that's a tree. DB is a directory, so that's a tree, and so on. And then the things that are files correspond to this third type, which is a blob. So let's try this cat file again on a blob. Well, let's go with that because we're trying to trace down where @py is. Let's try that. So let's grab those first few characters, 3, 2, 4, E2. Oh, look. That's exactly like what we did when we just said cats. You know, we didn't use any gitcat file. We just said, you know, Unix cat. And so that's our third type of Git object is, you know, the commit, the tree, and the blob. And basically those are the three types. There's kind of one or two other subtypes, but that is the essence of what Git uses to organize all of its files and directories. And so that is certainly a whirlwind tour. Apologize for that. This was a whole session last time. But those are the three types of Git objects that you have in play whenever you're doing anything with Git. When you're doing a Git commit or Git add or you know, Git merge, Git branch, it's making these SHAs and turning your files and directories into trees, and then attaching those trees to commits. And then you are, you know, attaching your dates and your committer and your comment, and then hashing all that and turning that into yet another reference. So then you've got a commit reference that goes into the database. And so one more thing we'll do, because that's all we'll have time for. Where is that thing in the actual database? Right, we've got this gitcat file, which is our app.py, which is a blob. And recall that we went and pulled out we went to all the trouble of pulling out these objects, right? So where is this 324E2? And the way Git does this is it takes the first two characters and it uses that as the directory name. And then the rest of that blob, or the rest of that SHA, is going to be the file name. So if I take .git / objects, ls space .git / objects, and then 3.2. So there should be a 3.2 in here somewhere in this list of directories. So there it is down there. So 3.2, and then 4E2 is the next. So if I type 4E2, 3.2 / 4E2, and then I should be able to hit tab and find the rest of it. And indeed, there it is. So this file, this blob, the content of it lives right down in this file right here, this git objects, blah, 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 blah. Now you may think, well, let's just go look at it then. Well, it's not so easy because Git also compresses it first and then it runs the hash on it. So if we just try to look at it, it's going to mess up your screen. Like so. So if I just say cat, like that, yeah, then I've probably messed up my terminal pretty bad. I need to restart it because it's binary. It's this sort of compressed format. That's why I need to use, gitcat file, because gitcat file knows how to uncompress it and then show it to me in its original content. But that's just an example of showing you that, this is the Git database, is this objects directory. It has everything that you've got. I'll say one more thing, and then I will leave a little bit of time for questions if there are any, and then we'll talk about the next session and what to do for that. So, so the one thing to keep in mind about Git itself is that these things don't go away. So, for instance, if I have app.py and I change it here, and maybe I take some lines out, right, and then I save it. So let's say, so I can use git status. And don't worry, I'll go over all this next class period, but I'm just showing you what happens with the objects here with Git when you make changes. So here it is. So I'll say I'm going to do a git add with app.py, and then I'm going to do a git commit. And then -m will say that's as my comment. Bad change. Okay. Now notice now I've got a commit SHA that goes with that commit. So is that in my directory? Let's see. Let's do an ls .git / objects / first two characters is 2D / F65 tab. And sure enough, there it is. And if I do a ls-l, I can see that it was just now created, right? 11:45 is my date now. So this just got there when I did that commit. But what if I don't want it? It's a bad commit, right? If I do an adog, right, here it is. Here's that 2D65 I was talking about. There's the SHA that goes with that commit. Here's where I'm pointing. That's a bad change. So I can go back before that and just go away from that change. There's a git revert I could use, which again, I'll show all this the next class when we have time here. I could also do a git reset and go back to the previous place. So a hard reset takes me all the way back to where I was before. Now, if I just typed head, it would take me back to the same place I'm already at. So Git has a notation of basically navigating around to say, go to the place you were before or some arbitrary location. And so the way it does that is with this caret sign after head. So that says, go to the place before head. And so then I go back to where I was before. But the point the long way around to the point I'm getting to, is this thing gone now? Because if I go and look at it, okay, it doesn't show up at the top anymore like it used to. If I go down, I'm back where I was before down here. So is that change still there? Well, in fact, it is. So if I go to list that object again, the object is still there in the database, right? I would take that away with you. The object is still there, which means, if I wanted to get back to it, I could, and we'll talk about that next time. But Git doesn't throw things away when you throw them away, if you will. It's still there. And so I could actually, do a checkout, with a new branch, and I could actually give this object to it, this 2D F65. Sorry, checkout -B, new branch, my fault. And now, if I do an ADOG, now my branch is pointing to that commit that I did before that I moved away from. So it was still there. I didn't recreate it. I just pointed something to it now, and now I can work with it again. So I know this is very hand wavy and very, very rapid, but the point I want to make is that Git has your back in terms of having the stuff that you are working with, even if it seems like you're in a really dark place. As far as you're not knowing where your code is or what you've just done, Git provides ways for you to get back and kind of try it again. If you have a bad merge and you make changes and they don't work, you can go back to where you were before. And I'll show you how to find those places where you were before. Git has a reference log that you can use, among other ways, so you can get back to a good place. And that's what we'll cover in the next session as we begin to collaborate and try to manage merge collisions and conflicts and things like that, and mistakes in Git, which I make all kinds of. Hopefully by the end of next session, we'll be in a place where you can recover from your mistakes, as well as do good things with Git without making mistakes. So I know we've been in the command line and in strange places and unfamiliar places all session here with the Python Flask and Pee-wee and the bash environment. But even when you're up in when you're in VS Code, all this stuff is underneath what you're doing. The environment is underneath this UI. Git is underneath this UI. And at some point, you're going to have to go down underneath, where you're at in the UI, underneath the convenience layer, if you will, and figure out what's really going on. Because this stuff all sits on top of what we just looked at today, and what we'll be looking at with the next session. And so once we get our grounding in that, it'll help you keep moving forward. That's pretty much all we have time for. Any questions before we sign off for the day and meet 2 weeks from today? If you have questions at any time, just go ahead.
I was gonna ask Chris, how did it work before Git was invented or GitHub?
Before Git?
Yeah.
Very excellent question. So first of all, Git and GitHub are two separate things. That's important to know.
Yep.
Git was around long before GitHub, 2002-ish, I want to say. GitHub is a social media or social coding layer on top of Git. So things with forks and pulls or forks and pull requests are GitHub layer. Pushes and pulls are Git, but all the comments and the code reviews and the workflows, that's GitHub, and Git sits underneath that. So we're going to be looking at Git itself, just FYI, more than we are the GitHub part. But once you know the core, then you'll be able to understand what's going on with the different kinds of workflows that you may choose to use down the road. Before Git, there still is. There are things like Subversion, Mercurial, ClearCase, Accurev, a whole raft of different kinds of source code control, SCCS, RCS. I'm drawing a blank now, but there are a bunch. The thing that Git added, I think, was the it did a good job of implementing this distributed version control concept. So, like, if you've ever used Subversion, it has a central server, and you have to almost be connected to that central server all the time to get anything useful done. Git, as we saw today, has its entire history local. So you can do a Git, log and see all the history without ever touching github.com or any other central version control system. So you can do useful work, and you don't even have to put your work back up to that github.com. You could share work with each other. If you had public visibility, you could push anywhere you want. You don't have to push to one place. So, as long as you can see each other on the network, you can push and pull code back and forth to your repos. So that was huge, and still is for Git. It makes for a lot of sort of resiliency. If that central place should go down, you got your whole history still. You just push it back up. So, good question.
And before all of that, it was just directories and saving again and again.
Yeah. If it was way before all that, like SCCS had a notion of a dot directory, but it was like one for each directory that you made. So, I mean, Git has a dot directory, the .git, but everything is there, right? And you can share it. So you could version, but it was definitely a challenge to share what you version. It was a challenge to to move it around and collaborate with it. And the way you access history was also very, very sort of clunky, and also very much dependent on that server being up. So yeah, Git's also very fast. If you notice, you can pull down the whole history, and it doesn't take very long. And that's true with most Git repos. Now, you want to make sure that you don't put lots of big stuff in your Git repo for that reason. If you have huge artifacts, you could put it somewhere else and then reference it from your Git repo, because normally huge artifacts are not visible, like, for diffing anyway. Like, if you've got an image file, you can't diff an image file effectively with another image file. So it doesn't really necessarily belong in Git if it's tens of megabytes in size, especially. You can use another storage mechanism for it and then just pull it into your app from there. But people do it anyway. Most stuff is small enough that Git won't care a great deal about it. So, and it will take it. I mean, it'll certainly hash it. And So that all still works. All right, folks, thank you for your attention. I know it's been a whirlwind 3 hours. Please feel free to Slack me, anytime, and in the interim, and I'll get the rest of the curriculum up at least a week ahead of time, so give you a chance to look over it if you want to, and then we'll pick it up from there and do some project collaboration the next time around.
All right, thank you very much.
Thanks, Chris.
Yeah, thank you.
All right, guys,
Thanks a lot.
take care.
All right, cool. So that was a lot. It's very good. If you do have any Git crises, feel free to reach out to Chris. He's very knowledgeable and helpful. So so we do have to go over a challenge, but I'm gonna say let's go ahead and take lunch until 1, and then we'll come back and we'll try to quickly, half hour ish, we'll see, go over a challenge.
Bye. See you.